Very well. You are my favorite students. I am so proud with you. Okay. Uh-huh. Okay, what is the idea for the linear system of equations? Okay. This is two equations. Down. It's obvious. Equation, let me call name. Equation number one is the name of this equation. And equation number two. And this we can represent graphically. Suppose to understand the geometry idea, interpretation. Suppose that the first equation is a line, like that. This is the first, in blue color. And the second equation, in green color, is another line. The thing we try to find is the solution. Solution of the system is the intersection. In this case, we have only one. Unique solution. I want to explain in detail in few minutes. Okay? This is one case. This is the most popular case. This is 99% of the example that we are doing is like that. Unique solution, only one. However, we have another possibility. No? We have the possibility in which, for example, the equation 1 in blue and the equation 2 in green, they are parallel and never touch and never meet. Therefore, this is the case that we have no solution. Okay? No solution. They are not a common point. And the last possibility is that we have, for example, the equation 1, the blue, and the equation 2, the green, is exactly the same. They are coincident. This situation sometimes happen, and this we have infinity many solutions. How do you know that? Algebraically, let's see now. I bring a lot of examples to illustrate very well this idea. Okay? But you need to be aware that there are three possibilities. Unique solution is the most popular, no solution, and infinity many solutions. Let me write again the example 20. The example 20 is, example 20 is 20. X, this is the classical format to write the system. You copy the first equation in a standard form, standard. You copy the second equation also in a standard form, not necessarily in a standard, but it's okay. Equals 16, and now you enclose everything using this curly bracket to indicate that this corresponds with the same mathematical problem. Okay, equation 1, equation 2. So we have two methods. Algebraically, we have two methods for solving the linear system of equations. The first one is substitution. Okay, substitution is the first one. The second is elimination. But elimination we study after. Okay, and in the real life, you solve it in either way. But today, not right now, we practice substitution. Substitution is good. It's good when we have one variable like that. Look. Whose coefficient is 1 or negative 1. So you see this situation, this is super good to do by substitution. Otherwise, no. Otherwise, much better elimination. Okay, then you take the equation that contains coefficient 1 and you solve for that variable. So suppose I want to copy again, x plus ay equal 15. And you solve for x. X is equal 15 minus ay. Okay? Now, you substitution, this is the name of the method, substitution, this expression here, in another equation. Look here. Here. In another equation. So far we have minus 2, parentheses, 15 minus ay plus 7y equals 16. Entonces in that moment we have one equation that contains only one variable que es y. You remove the parentheses, apply distributive property, minus 30 plus 16y plus 7y equals 16, no? We combine like term here and here, minus 30 plus 23. Why? Because 16 plus 7 is 23 equals 16. Okay, now almost we finish. Entonces 16 plus 30 is 46, no? And finally, divided by 23 both sides, y2. Now, to find a solution, we need the point. And the point contains two components, x, comma, y. We found y. I need to find x. So use substitution in either equation. The beauty is, if we can use in the equation 1, equation 2, but in my opinion, it's much better using this equation because x is already isolated. So x is equal 15 minus ay, but y is 2, I know. Entonces x is equal 15 minus 16, multiplication 2 times a, 16, now is a negative 1. And the solution then, we have only one solution, unique solution, is the order pair negative 1, comma 2. Okay, you write in that order, no? X first, this is the x value, and this is the y value. Any question?
I have a question.
Please, go ahead.
If I multiply the first equation by -2, and the
Yeah.
second,
You are right.
that'll be true, right?
This is elimination, mister. This is
Yeah.
elimination.
Okay.
I promise that we are doing in different way. But
Okay.
basically, I want, so you have two possibilities, substitution, elimination. And the real life, you make a decision to do and the way you consider better for you. However, I need to explain substitution now, okay? A substitution is good, in my opinion, when the one equation contains coefficients 1 or negative 1. Otherwise, in my opinion also, it's better the way you try to explain in general, elimination. Any other question? Everyone follow me? Do you remember this in high school, in middle school, or no? Okay. This is 21. Okay. This is a system of equation to equation 1 and 2. System. Yeah, I want to solve this. Okay. I can see, wow, look at that. I can see that the equation 2, every coefficient are even number. There are no reason. So you can simplification a little bit. If you divide by 2, by 2, and by 2, this is x plus 3y equal 24. And this equation, number 2, is equivalent to this equation. It's the same equation. Okay, when you multiply or divide any equation, the entire equation by a number, you get another equation that is equivalent to the original equation, and this is easier. Okay, now my problem is x plus 5y equal 40, and x plus 3y equal 24. Equation 1 and equation 2 exactly the same of the original. Okay, so now, for example, I make a decision because I need to solve in that. You take the first equation and solve for x because the coefficient here is 1. Also is 1 here. You take either one. So it's x is equal 40 minus 5y. And now substitution is expression. Another equation here. Okay? So it's 40 minus 5y. Plus 5y equal 40. Wow, something weird happened here, right? Because you apply this. Sorry. I make a mistake. Forget about it. This. use substitution here. Entonces 40 minus 5y plus 3y equal 24. Correct? I substitution in the first one. No, it's so wrong. Use substitution in the second. In another equation. Okay, now we combine like term. These and these are like term. So 40, I bring down 40 minus 2y equal 24. Minus 2y is equal 24 minus 40. So you're subtracting 24 minus 40. 40 minus 24, put in the calculator. 40 minus 24, 16, but negative 16, of course. Divided by negative 2 both sides. Y is 8. You want to find the x value, use substitution in the original equation, or in my opinion, the use substitution here is much better. That is 8 substitution here. Therefore, x is equal to 40 minus 5 times 8. 5 times 8 is 40. Entonces, es coincidencia que 40 minus 40 is 0. Therefore, x is 0, and the solution for this system is the order pair 0,8. Because the x component is 0 and the y component is 8. Is it easy or complicated?
Easy.
Easy. Okay. Go, moving on to the next. Next. Okay, next x. 21, 22. Sure. 22. So 22 is x plus 6y is equal minus 3 and 3x plus 7y equal negative 9. Okay, this very important, guys. Pay attention when you copy the equation, because I see in the test that you change the sign or change the number. So you are doing another problem different to the problem in the test. Some students, no, everyone. But some students change the number or change the signs. They say negative 5, you put positive 5. Why? You are solving another problem, no? So be careful. It's natural, I understand. Maybe I make a mistake like that, no? But well, okay. I passed this class, you don't. Okay, entonces substitution one more time. I can see que the coefficient here is 1. Good. I take advantage of this. Because I copy x plus 6y equal minus 3. Solve for x is minus 3 minus 6y. Now substitution, this expression here. So we have 3 times parentheses. It's important enclosing the parentheses this expression because this is x value. This is entire expression corresponding with the x. So this 3 multiply whole thing. Plus 7y equal negative 9. Good. Okay, now I apply distributive property because I want to remove parentheses. This is negative 9 minus 18y plus 7y equal negative 9. And we combine like term, why not? This and this together is 11, no? 11, yeah. Entonces minus 9 minus 11y equal negative 9. Entonces minus 11y is equal minus 9 plus 9. As I move, I bring this negative 9 to the right-hand side. This is 0. Ooh, it's canceled. minus 11y equals 0. Therefore, divided by negative 11, also is obvious. If y is 0, because 0 divided by any number is 0. Now substitution, this solution in here. X is equal minus 3 minus 6 times 0, because y I know is 0. X is minus 3. The solution then is minus 3. Any question? Substitution. It's one possibility for solving linear system of equations. May I erase the board or not yet? Guy, are you there?
Yep.
Okay. You follow me?
Yes.
Sure? Remember, I am your friend, I am your teacher, you are my business. For me, it's important that you learn.
Wait, so whatever you use to solve for y, you have to use that same solution to solve for x?
Yeah, depending on the problem, mister. In this case, was easy. Apply substitution in x because the coefficient is 1. But it doesn't matter. In another problem, maybe we are doing different. In this case, was a coincidence que it's x. I don't know, see, you see in another problem. No, mira, look, next problem is different. 23rd is different. I suppose que 23rd answer your question. But not always is x. Depends on the problem. 23, in 23, the system is 5x plus y equal 45, equation 1, and 5x equal to y. Wow, it's weird. Let me ask a question. What do you consider is the equation that we're using to apply substitution? What is the variable that contains coefficient 1 or negative 1? And what equation and what variable?
Say it again, please.
Say it again. Remember the key idea for the substitution. Key idea is I need to discover if we have one equation contain one variable whose coefficient is 1 or negative 1. So you see.
Yeah, you can multiply by negative 1.
Doesn't matter, positive 1 or negative 1. It's good.
Negative. Oh, okay, you said doesn't matter.
Okay. My question was, I can see here coefficient 1. Yes or no?
Yes.
Because I using these coefficients for substitution. Okay, let's do it. I copy again one more time the equation 1. So you detecting if in one equation we have coefficient 1 or negative 1. When you're detecting this, you immediately isolate this variable. Okay, 45 minus 5x. And you substitution this expression now here in y value because it's y. So you copy 5x is equal to time parenthesis 45 minus 5x. You see, mister, que no always is x, sometimes it's x or sometimes it's y, depending the variable que contain coefficient 1 or negative 1. You apply distributive property here. So we have 5x is equal to 90. Multiplication 45 times 2 minus x. Now I try to solve for x. To solve for x, I propose you move this negative 10 to the left hand side, like a positive, so 5x plus 10x equal 90. You combine like 10, 15x equal 90, divided by 15 both sides. And you put in the calculator, no? 90 over 15. 6. The answer is x equals 6. In order to find the y value associated with the solution, you substitution this 6 here. Y is equal 45 minus 5 times 6. Y is equal 45 Multiplication, this is 30, and subtraction is 50. Therefore, the solution is the order pair 6,50. Like the option A in the package. Do you see or no? It's confusing, it's clear? Remember, the arithmetic part is not important. I suppose everyone have calculator. You are doing fast the operation, subtraction, when it's complicated, when the decimal. I don't care the arithmetic part. I care the algebra part. How you manipulate the equation. Guy, I don't feel today you. Everything is okay. We're doing well. Too fast.
Yeah, everything is fine.
Everything is fine. Everyone is agree with him? Okay, good. You say like that. Oh, good, very good. Okay. We come back to the whiteboard. I want to erase everything. Okay, whiteboard. Good. 24 now. Huh? 24. 24 is y minus 5x equal 8. This is my first equation. My second is 5y minus x equal 4. This is a good example to illustrate that not always the equation is given in the nice way. Because the nice way, I suppose, que es standard, no? Standard form, que you know, is something like that. ax plus by equals c. The x first, y second, and the right-hand side is just a number. In this case, I switch